Good afternoon, pre-cal students. Today we're going to be talking about rational exponents. Rational, obviously, we just came off a big unit on rationals, which means fractions, ratios. Rational exponents, b to the m over n. Easy way to remember this, b to the m is obviously b to a regular exponent. But if it's a fraction, the denominator is a root. So the denominator is a root, right? For example, 100 to the 1/2 power is the same thing as saying the square root of 100, which is 10. Most people know that. Good. So using some of our laws of exponents, 16 to the 3/2 to the 1/2 seems really intimidating. Multiply these straight across at one another. We're raising a power to a power. So 3 times 1 is 3. 2 times 2 is 4. 16 to the 3/4. Which is also the same as saying the 4th root of 16 cubed. Just so happens that the 4th root of 16 is 2, and 2 cubed is 8. Negative 27 to the 2/3 is the same thing as saying negative cubed root of 27 squared, which the cubed root of 27 is 9, so it's is 3 rather. So the question here is what order to do this in. The negative always stays outside for last because of order of operations. Parentheses, then exponents, then multiplication. So it's going to be a negative 3 squared, which is 9. This one, we have negative 27. Notice the placement on the negative is different here. It's inside of the 27 now. It's the cubed root squared, and the cubed root of negative 27 is negative 3. Squared is positive 9. Same thing's just different placement of the negative here. This is going to be 1 over 27 to the 2/3 power. Flip the negative down. Which 27 to the 2/3 power we said is 9, right? Cube root of 27 is 3, squared is 9, so this is 1 over 9.
Hey, thanks for taking your time.
Yeah, no worries.
All right, I'll feel
Yep.
you.
Number 6. On here, negative 4 to the 3/2 power, same old. Negative 4. This is the square root, cubed. Now, thank you. Interesting thing happening here is that we have a square root of a negative number, which is not real. So there is no answer there. It's just a non-real number. Square root of a negative can't happen. Bye, ladies. Bye. People taking tests here. Elizabeth's here taking a test. She'll watch the video now because her name's been called out. Oh. Anyway. So express in simplest form. Use positive rational exponents. Major here. Positive rational exponents. You have to use positive exponents here. Never leave any negatives. You knew that already. Number 7, lots of interesting stuff going on here. First, it's the 6th root of all this, so I'm going to start by rewriting it like this. To the 1/6 squared. Now what that's going to let me do is combine these two guys, 1/6 and 2. Uh, 1/6 and 2 will be 2/6, which is a third. And then we can distribute that. 8 to the 1/3 is 2. A to the negative 1/3. B to the 2/3. Which you remember is 2b to the 2/3 over a to the 1/3. Now when you're dealing with variables, leave it like that. You don't have to write them as roots again. Ain't no point. First thing I'm going to do here is rewrite this as x to the 1/2, x to the Remember, this is the denominator here, 1/3 x to the 1/6. Multiply them all. You're multiplying bases all together, so you add their exponents. So this is going to be x to the 1/2 plus 1/3 plus 1/6, and you can't do that obviously because they need to be common denominators. So this is x to the 3/6, 2/6, 1/6, which is 3, 4, 5, 6, which is x to the 1 power.
Hey, x.
Fast and Furious, I like this stuff. Number 9. Distributing here, we have 3x to the negative 1/3 times x to the negative 1/3. So you add their exponents together. Just like if this was x and this was x cubed, it'd be x to the 4th. Negative 1/3 plus 1/3 is 0, so you get 3x to the 0. Minus 3 times 4 is 12. X to the 3/3, which is 3, x to the 0 goes away, minus 12x to the 1. Love it. Fast and Furious. Okay. 16 to the negative 1/2. Multiplying these together here, a to the negative 4/6. B to the negative 1/4, which can obviously be simplified down. 1 over 16 to the 1/2 is 4, so it'll be 16 to the 1/2 down here. A to the 2/3 and B to the 1/4. Too simple. Love it. Solve. Okay. Solving something. This is actually a neat skill to learn. Talking about how to get rid of these things. 3/2 is 64. Now I'm going to work this two ways, and I'll show you the quick way at the second portion. The first way, think about this. This is really the square root of x cubed, right? So you could go through and then square both sides. That's going to be x cubed equals 64 squared, whatever that number is. And then cubed root both sides. That'll be the cubed root of 64 squared. Yikes. Or the other option is simply raising this to the 2/3 power. Because that's basically what you're doing, right? These will cancel and make it x to the 1st power. And 64 to the 2/3. That's the cubed root of 64 squared. Now the cubed root of 64 is 4. 4 squared is 16. So it's a lot easier if you just raise it to the power that's the reciprocal, flip the fraction. So over here, let's apply that concept here. X minus 1 to the 2/3. First thing I'm going to do is x minus 1, and I'm going to raise that to the 3/2. Both sides to the 3/2. And what that does is let me get rid of my exponents completely. Okay, so we got x minus 1, these 25 cubed square root, so square root of 25 is 5, cubed is 125, so this will be positive and negative 125. Why positive and negative? We just took the square root, didn't we? We forced a square root into this equation when there was none to be had originally. And when you force a square root, you also have to compensate for the plus and minus. So we've got x minus 1 equals 125. We got x plus 1, or x minus 1 equals negative 125. Set them up and solve. X minus 1 equals a negative 125. We've got two answers here. X could equal 126, or x could equal negative 124. Both those are acceptable. There's a lot of graphing that goes into this. I ain't taking time for that. Graphing this stuff is really irrelevant. We ain't going to waste time with that. Punch it into y equals for all I care and get a graph. Graphing I'm not really harping on very much this unit. It's all about laws of exponents. Peace!